In this next set of examples, we're going to look at some additional multi-step inequalities that we could solve. The first one we're going to look at is 7p minus 11p plus 3 is greater than or equal to 3 minus 4p. So when we look at this, we notice over here on this left-hand side, we have two like terms. We have 7p minus 11p. And so we need to go ahead and get those together. 7 minus 11 is negative 4p plus 3 is greater than or equal to 3 minus 4p. Now, as we saw in the last video, we know that when we have variables on both sides, we need to get them together, and we like our variables to be together on the left. So I'm going to take this negative 4p and I'm going to move it over. So I'm going to add 4p here, I'm going to add 4p here. But what just happened? Negative 4p plus 4p, well, that cancels out. And so all we have left over here is a 3, greater than or equal to 3, and negative 4p plus 4p again cancels out. So we've gotten rid of our variables, leaving us with just the statement 3 is greater than or equal to 3. Well, we've seen this before when we solved equations, when we lost our variables because they canceled out, and we were left with a statement. That meant, with just numbers, that meant that we had either a no solution or an all real numbers. And if you think back, we remember that the difference was whether the statement we were left with was true or not. This statement here, 3 is greater than or equal to 3, is a true statement, and so our answer then would be all real numbers, meaning we could pick any number that we could think of and plug it back in or substitute it back in the original inequality for p, and it would work. What makes this a true statement, in case you're questioning that, is because it has the or equal to part. 3 is greater than or equal to 3. Well, 3 is equal to 3, so that would be true, making it all real numbers. Let's take a look at another one. We have 2 times the quantity 3d minus 4 is less than 4 plus 6d minus 15. Now, when we look at this over on the left-hand side, we have a 2 being multiplied by a quantity in parentheses. Now, in our last video, we looked at a problem similar to this where we had two different ways we could do it. We could distribute, or we could divide both sides by 2. In this particular setup, we would not want to divide both sides by 2 because we have multiple terms on the other side, and they are not all divisible by 2. So in this case, we're going to want to distribute. So 2 times 3d is 6d minus 2 times 4 is 8. And then over here, bring down our sign as less than, we have a 4 plus 6d minus 15. The 4 and the negative 15 are like terms, so we want to combine them. 4 minus 15 is negative 11, and then bring down our plus 6d. Now we want to get the d's together on the left side, so I'm going to subtract 6d here, subtract 6d there, and again, what happens? 6d minus 6d cancels, leaving us with negative 8 is less than negative 11. 6d's cancel here. So now we need to look at this statement. Is negative 8 less than negative 11? And we need to remember, since we're dealing with negatives, things are a little different than if these were positive numbers. It may help you to draw a number line. If 0 is here and negative 8 was here, negative 11 would be here, which means negative 8 is larger than negative 11, not smaller. So this would be a false statement, meaning that our solution then is no solution. Meaning that there is not a number that we could pick that we could substitute in for d in the original inequality and get a correct or true statement. Let's try another one. We have 4 times the quantity 3 minus 2x is greater than 2 times the quantity 6 minus 4x. So in this case, we've got a number times a quantity on both sides, so we want to go ahead and distribute both sides. So on the left-hand side here, we have 12 minus 8x is greater than, and on the right side, 12 minus 8x. Well, we should notice at this point that we have exactly the same thing on both sides. And we have a greater than, not a greater than or equal to. So at this point right here, we should recognize that this is an all real numbers problem. However, if you weren't paying that close of attention, you would follow along our steps from before, which is moving this 8x over, and we would add 8x to both sides. And the 8x's would both cancel, and we would be left with 12 is greater than 12. Well, in this case, this is not a true statement because 12 is not greater than 12. 12 is equal to 12. So this is, I messed up over here. I should have said no solution because we had the same thing equal to, or one of the itself greater than itself. So this would be a no solution. Number 4, our last example here, we have negative 4n plus 11 is less than negative 4 times n plus 6. So again, we want to distribute over here. So we have negative 4n plus 11 is less than negative 4n plus, we've got a negative times a positive. So that's going to be negative 4n minus 24. So again, we want to add 4n to both sides, which makes those cancel, and we have 11 is less than negative 24. 11 is not less than negative 24, and so this would be a no solution.